Objective number 5. Find the domain of a function defined by an equation. We will use the 3 steps below to find the domain of the function. First of all, we always start with a set of all real numbers for the domain, and then we look at the equation to see if it has the denominator. Then we need to exclude any numbers for which the denominator is 0, or we look at the equation contains any radical with even index. If it contains radical with even index, we need to exclude any number for which the expression inside the radical is negative. In part A, the problem f of x equals x squared plus 5x does not have the denominator, does not have the radical. So you stop at step 1 and eliminate step 2 and step 3. So the domain is all real number for problem A. The answer for all real number is in the set builder notation is x, and x is a real number. And in the interval notation is from negative infinity to positive infinity. You will choose either way to answer because the problem don't tell you which one that they want you to answer, so either way. In problem B, g of x equals 3x over x squared minus 4. So this one has the denominator. You begin with all real number and exclude a value of the x that make the denominator 0. We need to exclude that. So the x have to be positive 2 or negative 2. Then the denominator will be 0, and we need to exclude that. In order to see it, you can make it equal to 0 and solve. Then you say all of the value of x. X is a real number, and x exclude positive 2, negative 2. Problem C, each of t contains a radical. So in step number 3, it said that we need to make the radical negative and exclude that. I will do opposite, okay? Instead of make negative and exclude, so I just make the radical. The radical is under the radical 4 minus 3t greater than or equal to 0. So I just have to find the t that make it positive. Then we will minus 4 both sides first, and then divided by negative 3. Then t less than or equal to 4 over 3. So I want to go back to this and write a note for this. So you just have to make the radical greater than or equal to 0. That means this is opposite to the negative. So you will take any t that less than t 4 over 3 or equal to 4 over 3. And part D, this problem, we will start with all real number, and in this problem is contain both radical and denominator. So in the denominator, we need to exclude a value that make it equal to 0. Then we need to exclude 5 because when you put in 5, it will be 0. And the index is even, so we will do 3x plus 12. Similarly, like part C, greater than or equal to 0. We will solve for the x. And combine both of them because they are both in one problem. So let's draw the interval notation first for the x greater than or equal to negative 4. You have a negative 4 somewhere here, and x greater than or equal to negative 4 is on the right side, you're gonna put the bracket. That means any number that greater than or equal to negative 4. And you see what is that 5 is somewhere here. We need to exclude the 5 in that interval. So the answer for this problem will be from negative 4, 5. We're not including 5. Union 5 to infinity. In the set builder notation, you can answer all of the value of x such that x greater than negative 4 and x not equal to 5. We go back to part C. We can answer all of the t such that t less than or equal to 4/3.